Hi, it's Miss Murphy. We're going to do a quick lesson on acceleration. These are going to be calculations, and then we'll do acceleration in graphs. All right. I'm going to share my screen and share. Let's see. Is this working? All right, cool. We're going to keep this short and sweet. All right. This is, I believe, 1.5 acceleration, and we'll keep this to word problems. All right. Okay, first deal, when we mention acceleration, there's three ways an object can accelerate. The object can speed up. The object could slow down. Notice both of these represent a change in speed or velocity. All right. Not common is that an object is also said to be accelerating if it changes direction. So if you consider a ceiling fan that's going around, around, it's also accelerating. Now, if an object speeds up, acceleration will have a positive value, and if an object is slowing down, it will have a negative value. It could also be said that this is to decelerate. All right. To slow down. Okay, so there is an equation for calculating acceleration. We know that acceleration equals change in velocity over time. All right, we can put some symbols with that. Acceleration equals delta. Okay, yes, that's a triangle. This triangle is referred to as delta. It is a Greek letter and it means change. All right. And then next to that, we'll have V, and that is for our velocity. So, velocity. So, what we mean by that is the term triangle V means delta V, which means change in velocity. All right. When you get your change in velocity, it will be your final. No, let me do that differently. It'll be your velocity 2 minus your velocity 1. This is your final. This is your initial. This is your first speed. This is your second speed. Okay. And that's how you will get this delta V term right here. You will just take the final speed, and from it, you will subtract the initial speed. Okay. And then once you subtract that, you will divide that speed by the time. Okay. Now, let's just look at an example. And recall, if you are at rest, then your speed is 0 meters per second. If you are stopped or come to a stop, then your speed is 0 meters per second. Okay. So what we will do is we will have an object in motion, has an initial speed of, let's say, 10 meters per second, travels for 30 seconds, and its final speed is, let's say, that's going to be 70. Oops, sorry. Trying to keep our numbers simple here, is 70 meters per second. what is the object's acceleration? Okay. Well, let's see if we can get this out of the way here. Now, let's analyze the best way for you to solve a problem. An object in motion has an initial speed of, all right, so there's a piece of data, and I'm going to write this down. I am told that my initial speed, that's V1, equals 10 meters per second. I'm going to continue reading. Travels for 30 seconds. There's another important piece of information. Seconds is a unit of time. So time equals 30. Oops, let's make that easier. 30 seconds, right? Or S. Go back to the word problem, and its final speed is, all right, something else that's another important piece of information. Speed final is 70 meters per second. So velocity final equals 70 meters per second. Back to the word problem. What is the object's acceleration? So I see this is the question they're asking me. Question mark, acceleration. So notice I'm now done with the word problem. Okay. This is everything, the information that the word problem has given me. So I don't need to continue to read that word problem. I see that I am asked for acceleration. So I'll write the formula for acceleration. Okay, so now I'm just going to plug in A equals V2. I see that, I put VF, that means the same as V2, my bad. Final, second, last, remember there's the 2, so that's 70. So we'll put 70 meters per second here, minus V1, well, that's right there. So I'll put minus 10 meters per second divided by T. T is right there at 30 seconds, okay? Now, I'm just going to do 70 minus 10. That equals 60. And then a meters per second minus a meters per second is a meters per second. We'll divide that, and I'll just carry this over by 30 seconds. All right. Now, I'm going to do 60 divided by 30 equals 2. And I've got a meters per second divided by a per second. So notice I've got it 2 seconds on bottom. So I'll keep my meters on top, and I'll put 2 seconds on bottom. So my answer is my acceleration is 2 meters per second squared. Okay, so we see that for speed, our units would be like meters per second, where our acceleration, our units would be meters per second squared. So this shows us how fast, how much faster we move each second. And this tells us how fast we are moving. All right, I'm going to end it there. All right. Maybe, yeah, let's go ahead and end that. Solving for acceleration using word problems. All right. That's all we did. Once again, accelerations is to speed up, slow down, or change directions. So a ceiling fan is said to be accelerating. I'm going to stop share, and I'm going to end my recording.